Okay, everybody, here is the Chapter 8 review, which deals with trig graphs, trig identities, and trig equations. So I've got a little bit of everything in here. So let's take a look. First problem is a -3 sine 3 x minus pi 4 subtract 2. So I need a sine curve, but it's upside down. Okay. I need to get 3 curves within the 2 pi. So I took the 2 pi and divided by 3. So each curve is going to be 2 pi thirds in order to get 1, 2, 3 curves within that 2 pi. So I've got an amplitude of 3, so here's my first sine curve, and I did it in pencil. And here's my second curve, I did it in pencil. Here's my third sine curve. Now, that's just doing the basic curve. Now I got to move it. Do a translation, pi force to the right and down 2. So pi force is about here. It's a little bit less than pi thirds, so it's about 3 squares. So I took every point that I consider important points, max, mins, and zeros, and I moved every point over 3 squares, which is pi force, and down 2. So every one of these points has been moved or shifted over pi force and down 2, and then I just traced in the curve. Okay, there it is. Okay, number 2, I want to find the equation of this curve. Well, I could probably call it a sine if I started here, but I'm not sure where that is. So I really want to start here. I call it a cosine because I can find the maximum the easiest. So I went with cosine. The amplitude, if I have a hard time finding the amplitude, is max minus the min divided by 2, which is 6 over 2, which is 3. So the amplitude is 3. B, which is the frequency, is 2 pi always divided by the width. So the width of this curve is 8, okay? Has a span of 1, 2, 3, 4, 5, 6, 7, 8, okay? So 2 pi over 8 is the same thing as pi over 4. That's my frequency. The graph has been shifted 3 to the right, so minus 3 on the inside, and then it's been bumped up to the middle of the curve is right here at 2. If you have a hard time coming up with that value, the k is always the minimum, which is -1, plus your amplitude, which gives you 2, okay? All right, turn the page. Identities. All right, so on number 3, I foiled sine times sine, sine squared, sine times 1, 1 sine, -1 times sine, negative sine A, and -1. These two will cancel, and I'm going to put the sine squared minus 1. That's not quite the identity one, but if I factor out a -1 from this expression, I'll get a positive 1 minus sine squared, and that is an identity. That's going to be a cosine squared. That's a cosine squared, but a -1 cosine squared. Okay, 4. We've done this one before. We'll take a look at it again. Tangent, sine over cosine. Cotangent, cosine over sine. And then secant squares 1 over cosine. I need to add these two fractions, so I need a common denominator. Multiply by cosine over cosine, sine over sine, so that my common denominator is right here, sine cosine. All right, then I get a sine squared plus a cosine squared over my common denominator, sine cosine. All right. Now that's still being divided by 1 over cosine squared. Now this is a mess, but I'm going to fix it. So that is 1. That's an identity. That is 1 over sine cosine. And I'm going to flip it. Invert and multiply. So I multiply it times a cosine squared theta over 1. I don't really need the 1. One of these cosines cancels this cosine. You're left with a cosine over sine. So the identity is a tangent of x. Okay. Moving on. My page 2. Okay, number that was 1, 2, 3, 4. 5 is solving radian mode, and so I'm just going to solve it. -3 divided by 4. Tangent inverse, I use my calculator. Tangent inverse of -3/4 gives me a negative angle. I am between 0 and 2 pi, so I add 2 pi to it to make it positive, spin it all the way around. It has a second reference angle, and so the second reference angle is to take this first angle and subtract pi from it, because they're exactly pi apart, and I get a 2.498. Okay, number 6, cosecant squared minus 4, so I added 4, took the square root of that, square root of 4 is plus or minus 2, it's a cosecant, so I change that to 1 over sine, and then I flip it, I get a sine equals plus or minus 1/2. That's on the unit circle as pi 6 and 5 pi 6. That's on the unit circle at 7 pi 6 and 11 pi 6. Again, If I'm going too fast, just pause the video, okay? All right, number 7. Well, I'm thinking I better factor. So I brought over the tangent, 3 tangent, and I brought over the 1. So I subtracted 3 tangent, and I added the 1. I did a little bit of algebra here. It does factor. If I have 2x squared minus 3x plus 1, which is like this, and I factor, I get a 2x minus 1, x minus 1. But we're not doing x's, we're doing tangents, so it's really a 2 tangent of x minus 1 and a tangent of x minus 1. Okay, that creates my mini equations. 2 tangent of x minus 1 equals 0, and tangent of x minus 1 equals 0. I solve it, plus 1, divide by 2. Now, that is not on the unit circle. Tan of x equals 1/2 is not, so I use my calculator. Tan inverse of 1/2, it's about a 0.463. The other angle, the reference angle, I'm going to add pi to that. I get a 3.605. Okay, the second part to it, the 7, is I add 1. That is on the unit circle at pi fourths and 5 pi fourths. Okay, 8. I'm going to bring tangent over, and I recognize that I have a common tangent. So take out the tangent. I'd have a tangent minus 1. And then from here I get 2 mini equations. I've got tangent of x equals 0 and tangent minus 1 equals 0. That occurs on the unit circle at 0 and pi. I add 1, and that occurs on the unit circle at pi fourths and 5 pi fourths. Again, if this is going too fast, just pause the video, okay? All right. Next page, which is the tide problem, I believe. Should be the tide problem, yes. So here's my tide problem. At 2 a.m., high tide is 7. At 11 a.m., low tide at -2. So the first thing I do is I get these 2 points, and I need this next high tide to draw my curve. I know from high tide to low tide is 9 hours. So that means from low tide to high tide is another 9 hours. So I get my next high tide is really about 8 o'clock in the evening, okay? So if I want an equation, I'm going to start with cosine because it has a cosine shape. I need the amplitude. So the amplitude is maximum minus minimum divided by 2, which is going to be 9 over 2, which is 4.5. That's my amplitude. I need the frequency. To get the frequency is 2 pi, always 2 pi, divided by the curve width. Well, this curve width from high tide to the next high tide is 18. So I reduced 18 to 2 18ths to pi 9s. Now, the entire curve starts at 2, so it's at t minus 2. And then to get how much the curve has been moved up, it is 2.5. But if you're not sure, to get this last value, it's always the minimum, -2, plus the amplitude, which makes it 2.2. So k to 2.2, 2.5, sorry. And that goes right there. So that's my equation of my graph, okay? Now, if I want to find out what the high tide is at 8 o'clock, it looks like it's right about there. It looks like it's about 0. But to get exactly, I put 8 into my equation for t, and I use my calculator, and I get a 0.25 for my height, okay? So if you have any specific questions, please ask me, and then we'll take the quiz tomorrow. So good luck, and we'll just do it.